Welcome everybody. Now, I'm coming to you this time from my pole building, or pole barn if you like. Eventually this thing's going to get its own video, but I'm coming here because I like to do a variety of different locations for you. I mean, I have all this property and a couple buildings, so might as well liven up the background a little bit every time, right? And it's not outside because, well, it's been breezy, not too much right now, but now it's raining, and I can't have the camera and the microphone out in the rain, so figured I would just do this from inside here. It's a new variety place to film. And the fact that it's raining makes, especially this late in December, is unusual. It's not unheard of, but it's unusual. I mean, we can get, 60-some degree days in February and stuff. It happens. It's just, it's not likely. Likely it's going to be around freezing at this time of the year. Today, it got up to like 53 yesterday, and it will probably get up that high, or maybe even a little bit higher by the midday today. But, unusual, not unheard of. That's what's going on. And raining makes me think of talking about precipitation. Fancy word for water coming out of the sky, no matter what form it takes. Usually rain, though at this time of year, usually snow. There can also be hail and freezing rain and things like that. But, freezing rain's terrible. I wouldn't recommend it. It's probably the worst of the rain things because it accumulates on surfaces and makes them all slick and very dangerous. And it also weighs down power lines and things like that, and it causes them to detach from the transformers, and then everybody's without power. And that's pretty awful too. So yeah, ice is bad. So probably the worst condition that you're going to get in the wintertime here. But yeah, precipitation. Now here in America, we measure precipitation in inches of liquid water. Most of the rest of the world is metric. They usually measure in like millimeters, like Canadian radio stations here, because we're real close to the border, and they'll talk about how many millimeters they're going to get. So I'd imagine they all do that. Maybe some of them measure it in centimeters. I suppose it depends on how granular they want to be. But yeah, and that's an important thing, liquid water, because at this time of year, this being an exception, usually it's not coming down as liquid water. Now I talked about precipitation, or lack thereof, in my very first video on this channel, but the fact that we had very little, comparatively, this summer. It hasn't gotten any better. In fact, it's actually gotten worse. We had been in abnormally dry for most of the summer, like basically right from the beginning of the summer, like the end of June, all the way to late July. And then we moved into moderate drought briefly. Then a big rainstorm in early August. It always lags a little bit. The weather report, the drought report, will always fall a little behind what the actual events are, like a good week, just because of when they compile it. But, by mid-August, they had moved us back out of moderate drought in the southern end of this county, back to abnormally dry. And we stayed that way until the middle of last month, middle of November, basically. Then we moved back into moderate drought. And in the middle of this month, December, we moved into severe drought. Now, if we're going to have severe drought in an agricultural area like this, it's a good time to do it. Most of the crops aren't in the ground, with like one major exception. And trees, even like fruit trees and Christmas trees, they grow those around here too. They're not used to getting water very much during the winter time anyway, because it's coming down to snow and you can't, it doesn't absorb as liquid water like rain does. So, they're kind of used to it. The crop that's in the ground, by the way, at this time of year is wheat. Like the full name for it is winter wheat. They plant it in the early fall, like late September, early October, and it gets harvested in like late June to early July. but it's growing during the winter. In fact, you'll see it pop up before it starts to snow usually. You'll see a very low green colored covering on the fields that have the winter wheat in them, and that's it growing. But it's usually essentially dormant, not getting very much water or nutrients or anything like that during the winter time. It starts growing again in the spring. I have a little bit of kinship to it. At least around here, it's planted in late September and it's harvested in late June. I happen to be born late June, so being that it's about 9 months, basically my development cycle inside my mom was about the same as the winter wheat that year. So I have a kind of kinship to the crop, but it's not used to getting much rain, much water during this time of year either. So it's kind of fine if you're going to have a severe drought. This is the time to have it. Anyway, in that first video, toward the end, I talked about how much rain we get in general, how much precipitation we get, really, in general, for the whole year. We get about 30 inches. It's actually more like 30 and a half, but drop in the half and make the math easier. But it doesn't come down evenly throughout the year. If it did, it would be an average of about 2.5 inches a month. 30 divided by 12. But it's not like that. It's significantly more. May is actually our rainiest month. We get like 4 inches or something like that in May on average. And then it stays relatively high throughout June and all the way through the summer until October-ish. And it starts to drop off in November, and then through April it's less. The weakest months are like December, January, February. The coldest months too. And those two things are related. So there's a couple of reasons why it's not even. And they have to do with overall with the temperature in the wintertime. The wintertime is colder, and a couple things about that cause there to be just overall less total precipitation as it's measured. It doesn't mean that nothing falls out of the sky. In fact, we get about 40 inches of snow per year. But snow doesn't add up to rain 1-to-1, not even close. Most people will tell you about 10-to-1, but that's really for the wet, heady kind of stuff, which I talked about in an earlier video. It's the kind of stuff that falls and you can pack it up and make snowballs and snowmen and forts and whatever else with it. That's about 10-to-1. That's the densest kind of snow. It's the kind of snow that falls when the temperature is right around freezing. But if it gets much lower than that, into the upper 20s and below, it starts to come down as light powdery snow. It's the kind you want to ski on. It's a big difference. And it's much less dense. So your average is probably more like 12 inches of snow to 1 inch of total precipitation. So yeah, it's quite a bit of difference. So over those months, all that snow, all that 40 inches of snow adds up to maybe 4 inches, probably more like 3.5 or less. So you just don't get very much during those few months. Now, why is it like that? Why is snow so much less dense than water, liquid water? There's a few reasons. They all kind of add together. It has to do with some certain physical laws. Now, there are many states of matter, but really there's only about 3 that we run into on a day-to-day basis as human beings on planet Earth. And you probably learned about these in school and science class. So they go from higher temperature to lower temperature. They are gas, liquid, solid. And you can see I made a kind of a V pattern when I was doing that, because for most cases, basically all cases when it goes from gas to liquid, the same amount of matter condenses into a smaller volume. It becomes more organized as it drops down from gas to liquid, and then again from liquid to solid, generally. There's an exception coming up here, though. So pretty much everything, I've never heard of an exception to gas to liquid, where it gains volume. Never heard of an exception to that at all. And it makes sense. Gas is chaos. It's the air around you. If I move my hand like that, I've just scattered countless atoms and molecules in the atmosphere. Things that were once really close together, they've flown apart, possibly never to come anywhere near each other again. It's formless. It's gas. But liquid is a little more structured. It tends to want to come together. It follows the slope of whatever it lands on, and it pools, turns into puddles, things like that. Ponds, lakes, oceans, things like that. It wants to come together. You can still pretty easily separate out portions of it without too much effort. You get like a squeegee or something, sweep it right off to the side. A little chunk of it, you move it right off. But it will want to run right back to that same place. The same slope that drew it there to begin with is still there. It's going to want to come back on. So, and you can see it when drops of rain meet a puddle. They just go into it and they're just gone. They absorb right into it. There's no tracing them anymore. They're just part of the greater whole. So, it's more organized. Now, generally, like 99% plus of the time, when something changes from a liquid to a solid, it again loses volume. It becomes even more organized. And again, makes sense. They're solid. They want to stay together. They don't, they're going to run away. They aren't easy to separate out. You have to apply force to them. You have to pulverize them. You have to cut them. You have to do something like that. They want to stay together. And we use it as an adjective. Something is solid. It's a solid thing. It's hard to break. That's what solid means. So, yeah. But water and a couple of metals don't behave this way. They don't lose volume when they solidify. They, in fact, gain volume. Now, there's solid physical reasons for this. I didn't really get into it on what it is about the structure of those two particular metals that also do the expansion when they solidify. But I did look up what happens with water, why it does this. And it turns out a water molecule, it's a molecule, it's not an atom itself. It's made up of 3 atoms, 1 oxygen, 2 hydrogen. Now, oxygen and hydrogen are both needy. Their outer valence shell, where their outer electrons are, it's not full. And so they want to bond with other things to make that full. Everything looks to try and make its outer valence shell full if it possibly can. And 2 hydrogens will bond with 1 oxygen atom, make a molecule of water. They share 1 electron of their own with the oxygen molecule, and the oxygen molecule shares an electron with each of them. It stabilizes the outer shells on all of these things. It makes water a very stable substance. It no longer wants to bond once it forms a molecule of water. So those hydrogen atoms make the water molecule want to form into a hexagonal crystal when it solidifies. And you probably haven't seen this. I mean, you need like an electron microscope to see a single molecule of water, liquid or frozen. But you probably have seen the hexagonal nature of a bunch of water molecules formed together. A snowflake. If you've ever looked at photos of snowflakes taken, on a microscope, you probably haven't done it yourself. It's a pain, but they're hexagonal because those hexagonal single molecules that are solid just want to extrapolate out their same hexagonal pattern. It's called being fractal. It's where the small is replicated in the large, in the whole. Think of a fern leaf. If you've ever looked at a fern leaf, they're roughly triangular, and they have little fronds coming out on each side, staggered apart. If you turn it and look at like one of the bigger ones, especially, and especially if you can get under magnification, you'll see that each of the little fronds that makes up the overall structure of the fern leaf has that same pattern going on in it, and it goes down at least a couple levels, so it's fractal to a certain degree. It's probably not down to the cellular level of a plant or anything like that, but it's there. It goes pretty small, and it does replicate itself out in the same pattern a few times at least. So that's what the solid water molecules do too. The hexagonal single molecules form into hexagonal patterns like snowflakes. Now, you can see this also, like even if you look at like hexagons, like if you've ever seen like a bathroom with hexagonal tiles on the floor, you'll see that your eye will pick up a pattern in them. It'll want to do it, and it can be different every time. Like even if you blink, it could change to a different pattern. You might see a line of them just going in one direction, or you might see a triangle, or a diamond, which is basically just a triangle pointing both ways. Or it might make bigger and bigger hexagons, and that's the one that we're talking about. That's a fractal thing happening. So yeah, it does that, but they're not just chains of. It's not quite like a snowflake. At least it's not quite like the fractal patterns that you see of greater and greater hexagons on a tile floor. It would be instead irregular. The little nodes at each point and in the center, but they're linked by like long rails almost. And if you drew around those rails, you would see that if you drew like from the points of each point on the snowflake, if you drew like a hexagon around it, you'd see there's a lot of empty space there. So that makes up some of it. And the solidifying nature of the fact that water expands when it solidifies makes up some of it as well. But it's actually the smallest part of it. Now, water expands by about 9% when it freezes. You've probably seen this if you've ever had a soda or a beer. If you ran out of them in your refrigerator, but you had more that were sitting out room temperature, you don't want to drink them like that, and you want one soon, you can put it in the freezer. You may have done this in your lifetime. These things, they're like 99% water. There's very little other stuff in them, so they behave like water when you put them in the freezer. You leave it in there for an hour, generally. Depends on your freezer, really, but usually they're just a little bit below freezing. So about an hour per can is usually fine. It'll cool it down plenty. You might actually get some small ice crystals forming in it at that point, but not very many. And it's, you open it up and drink it, it's refreshing. So, yeah. But if you happen to get distracted, forget about it, called away, something like that, and you come back, like, say, 6 hours late, then it's frozen solid. And you've probably noticed, I choose a can because it's likely to expand but not rupture. It can around the lip where the top part is attached because it's a separate piece. So you can get a rupture there, but oftentimes you won't. But it'll just pop out at the top and bottom. And that's the expansion of the water as it freezes. That's that 9% happening. It's it's a small bit, but it's some of it. The other bit is the probably half of a snowflake is missing space. It's air. It's just if you look at it, probably probably half is missing. So that's another big part of it, and the rest of it has to do with how it falls on each other. They're solids, so they fall in piles, and you can easily sweep them apart. They don't generally break apart. You can, if it's wet and heavy, you can kind of pack it. It's denser. but it's still easy to rupture. I mean, when I did my demonstration, made a snowball, it broke in half, and I had to mush it back together. It doesn't, it doesn't maintain its integrity all that well because it's solid. Solids, you have to melt them down and refreeze them to make them into a whole piece. If they were in pieces to begin with, and that's what snowflakes are. They're just little pieces of frozen water. So when they fall on each other, there's a lot of space in between them. There's friction between them. There's air pockets and such. They don't just meld together. They stack up, and that makes up the rest of it. That's why there's so much less. So why is it that we don't get 2 to 2.5 times as much snow as we get during the winter? I mean, I'm glad we don't. I wouldn't want to have to deal. We get 40 inches. I wouldn't want to deal with 80 to 100. But why doesn't it just make that up and make it even out throughout the year? And that has to do with temperature, and something that you've probably heard your whole life but never really questioned what it really meant. And that term is relative humidity. Now, it doesn't mean that the humidity has brothers and sisters, parents, children, anything like that. It's not that kind of relative. It's relative to the temperature of the air that it is in. Humidity is basically water vapor in the air. Now, if you take a 1 cubic foot section of air, imagine an imaginary box that's like 1 foot wide by 1 foot deep by 1 foot tall. That's a cubic foot. And at 100 degrees Fahrenheit, it holds a lot more water than it does at negative 20 degrees Fahrenheit. I use those as my bounds because those are around what our record high and low temperatures are around here. A record high probably could be going up to about 110. It's not easy to find for rural, not so populated counties, like absolute records for like what the absolute hottest day ever was or what the absolute coldest was. But you can kind of extrapolate. I mean, we had a 95 degree day this year. That was our hottest. And it happens. I've seen negative 20 on my own thermometers. And you can kind of extrapolate that one from nearby places. Detroit's record low ever, about 50 miles south of here, was negative 20. Saginaw, about 45-ish miles that way, mostly west, a little bit north. They have a record low of like 21 below. So we're right in there. I know, like I said, I've seen negative 20, so I know what happens. It's not common, but it does happen. And there's a big difference in the amount of moisture in a 100 degree cubic foot of air versus a negative 20 degree cubic foot of air. It's the same reason why you could have 100% humidity in the wintertime and still be dry. Yeah, you get static electricity going on all over the place in the wintertime. And it's even very high humidity in a cold temperature can be quite dry. So that's what we have. We had that polar vortex, bomb cyclone, whatever, winter storm Elliott, whatever you wanted to call it, last week, just a week ago. It was like less than 10 degrees on last Friday. It's quite a difference between that and this Friday that just ending. Today we were at 53 or something like that. But they were predicting, the weather service, they gave us a warning that it would be between 4 and 8 inches of snow during that. But I looked at the temperature and I knew that it was going to be, if anything, it was going to be at the low end of that, just because by how fast it was going to drop. Because it just can't snow that much when it's 10 degrees or less outside. And it dropped real fast. It was right around freezing at about 2 a.m. By 10 a.m. or something like that, it was below 10. So, if it was going to do that, it would have had to drop a lot of snow all at once. We got quite a bit. Here's the secret. You can't really tell when there's that much wind, and it was very windy. It was like 20 some mile an hour winds sustained for most of the day. You can't really tell how much snow you get when there's that much wind. It blows across. I mean, my driveway was clear because the wind was just blowing it right across. It makes drifts and banks in places when it hits up against a vertical surface. It'll push the snow up to that, or it'll throw it over the roof of a building and drop a bunch of it on the opposite side. But yeah, and that's what we got. It was weird placement for it. We got snow drifts on the east side, and we usually don't get that. We usually get them on the south side, and then blowing up against the buildings, we'll get them on the west side. But we usually don't get much of a drift on the east side like we did this time. It was very windy, very weird, very strange storm. But it wasn't as bad as they said it was going to be. I would say probably 3 inches. It might have been 4. Maybe it was at the bottom end of what they predicted. It's possible. But it's really hard to say. you can tell if it's relatively still when the snow comes down. You can tell. It'll pile up everywhere, and you'll be able to see, as long as it isn't right at an eave of the house, because it will get a little heavier right there, a little deeper. But for the most part, you can get a pretty good look at what it was like out in the open if it isn't super windy. But it was this time. So, yeah. But I knew it was going to be less because of how cold it was going to get, how quickly it was going to happen. So unless it was going to drop 6 inches in an hour, which is pretty well unheard of around here, it wasn't going to get that high. It wasn't going to get up to 8 inches. Nutty. That's another thing about the drought, is that you're not going to snow your way out of it. Not here. Maybe in a mountain community where the clouds, in order to kind of push and get over the mountains, they'll drop all kinds of moisture, and that's why the mountains, like in the Sierras or the Rockies or something like that, they get a whole bunch of snow in the winter. Way more than what we get here. So for those places, they might get enough snow to negate a drought, but around here we just won't. You also might get it if you have a significant body of water in the direction that the weather generally comes from. Here in the U.S., mostly, if there's a big body of water to your west, you will probably get lake effect snow, and you might get extra, at least until that body of water freezes over. Once it freezes over, the lake effect snow basically stops because you can't suck the moisture out of it. But until then, you get it. They get it on the west side of Michigan a lot. They get a lot of lake effect snow. We generally don't. Can happen if the storm is stalled out and spinning around, and it's the backward end of it's coming this way off of Lake Huron. Then we can get lake effect snow, but it's pretty rare. I've only seen a significant amount of it once in 20 years of living here, so yeah, it's not very common. But yeah, that's just how it works. So yeah, that relative humidity, that makes all the difference. It's the reason that we don't get 100 inches of snow a year. We just it's too cold to make that snow happen, and we aren't in the right place for lake effect, and we're not up in a mountain slope that causes the clouds to drop a bunch of moisture on us, all of their moisture to try and get over. But yeah, that's a thing. So yeah, we're not going to snow our way out of this drought. It'll probably go away. We'll probably have another wet spring or something. Who knows? Maybe we'll have a nice wet summer. It happens. It wouldn't be the first time. Every one of these dry years is basically balanced out by a wetter than normal year. So it's bound to happen sooner or later. We've had enough dry years in a row. Basically, the odds are very good that we're going to have a pretty wet one coming up real soon, maybe even this next year. We shall see. But yeah, that's the precipitation story. And since it's warmer in May through into October, it, there's more moisture in the air to drop down when it does rain, so we get more rain, and that's why it's uneven like that. That's why it's not a nice flat line of 2.5 inches every month. So that's just how it goes. Anyway, it's been a little diversion, just something to talk about because of how it's raining and a little bit weird, but not so crazy to be out of the realm of possibility. And that's about it for the video. I thank you all for watching. I hope that you enjoyed this. Maybe you learned something. Who knows? Still all that stuff you can do at the bottom. Comment about what the rain is like where you come from, or something like that. And I hope you all have the best possible day that you can have. And I will see you soon. Take care.